Good evening all. Today topic for wireless cellular and LTE 4G broadband course is channel dependent multi-user resource scheduling, which comes under key enablers of the LTE features standardizations. In this particular slides, we will be talking also multi-antenna techniques. This is the third key enablers of the LTE features standardization for 4G wireless communications. Channel dependent multi-user resource scheduling. The FDMA, okay, that is we are using an AMPS that become very important in LTE features. That become in terms of OFDMA. This term scheme is used in LTE provides enormous flexibility in how channel resources are allocated. OFDMA allows for allocation in both time and frequency, and it is possible to design algorithm to allocate resources in a flexible and dynamic manner to meet arbitrary throughput, delay, and other requirements. The standard support dynamic channel dependent scheduling to enhance overall system capacity. In OFDM, it is possible to allocate subcarriers. Subcarriers. If we make carrier into subcarriers, definitely the capacity of the allocated channels to the subcarriers, it will increase among users in such a way that overall capacity increase. I told that also. This technique called frequency selective multi-user scheduling calls for focusing transmission power in each user best channel portion. You see the figure, that is resource mapping in OFDMA. OFDM, okay. This one is OFDMA. That is, you see that it is frequency division multiple axis orthogonal, and here O orthogonal frequency division multiplexing. In this you see the carrier they divided into subcarriers, okay, and there so that the number of channels channels allocated to various user 1 2 3 4 are increased, whereas initially it was two only, whereas it become now, okay, you can see that the one user 4 and user 4 it is getting multiplied, and that is why capacity is increased, and that is a good features of LTE. Scheduling. OFDMA frequency selective scheduling can be combined with multi-user time domain scheduling that we have seen above. Capacity gains are also obtained by adapting the modulations and coding the instantaneous S to I noise ratio, signal to noise ratio, that is increased. When the noise is less, definitely the power of the signal it will increase, and so that for it will increasing the efficiency, also the condition for each user subscriber. For high mobility users, OFDMA can be used to achieve frequency diversity by coding and interleaving across subcarriers. Frequency diverse scheduling is best suited for the control, signaling, and delay sensitive devices. If we talk about control signaling, you must be knowing the channel allocated for the control signaling that will be utilized in this particular, and it becomes delay sensitive services also it will be using this particular OFDMA technology. Key enables another LTE feature standard is a multi-antenna technique. In this, the LTE standard provides extensive support for implementing advanced multi-antenna solution to improve link robustness, system capacity, and spectral efficiency. Multi-antenna technique supported in LTE. We know that this technically this is HSPA that was used release 6 and HSPA release 7, where the OFDMA technology is being utilized for multi-input, multi-output MIMO, and that was the things is included in release 7. There, the multi-antenna, 4 antennas at the transmitting and 4 antennas at the receiver, it was used initially in release 7. The transmit diversity, very first technique we are using multi-antenna diversity technique. Diversity means send copies of same signal by using 2 or more communication channels with different characteristics. How it can be achieved? It can be technique to combat multipath fading in the wireless channel. So what we are doing it, we are sending the signals from the multi antennas, transmitting same signals with little bit different achieved characteristics, and so that the multipath fading it is happening the best, the signal achieved, and so that if it is getting the fading, the non-fading signals can be achieved for one or other one can be achieved at the receiver. LT transmit diversity is based on space frequency block coding. Space frequency block coding technique we use in LT transmit diversity. Transmit diversity is also primarily intended to common downlink channels and cannot be used for channel dependent scheduling. It increases system capacity and cell range also. Multi-antenna technique, you see here, it is data which is being transmitted diversity HSBC, and you can see that antenna 1 and antenna 2, the same data symbols is getting transmitted onto transmit signal. When it is getting the fading technology, we are using it where diversity, where the signals can be achieved one or other. That is very useful technique for indoor transmission of the signals. That is the mere cause of the problem in metropolitan cities where the high buildings and other things. This is a very useful technique. Another technique of multi-antenna, we have beamforming. It is a type of radio frequency management, beamforming, and signal processing technique in which an access point uses multiple antenna to send out same signal. Here multiple antennas in LT may also be used beamforming technique to transmit the beam in the direction of the receiver, whereas we are using other above one. There we have used transmit diversity continuation. There we are sending the signals from the various antennas we are not for beamforming, not for in the direction of receiver, maybe any receiver, any users, but in this it is in particular one direction only will be making the receiver, that is the entire intensity we are putting in the one direction. So we are making it beamforming technique to transmit beam in the direction of receiver and away from interference, thereby improving the received signal to interference ratio. It can provide significant improvement in coverage, range, capacity, reliability, and battery life too. It can also be useful in providing angular information for user tracking LTE support beamforming the downlink. You can see now the beamforming with the MIMO, okay, where it is the user one, maybe it is beamforming from 4 and 4. I told LTE using 4 and 4 antennas at the receiver and 4 and 4 at the point of transmitting, and that is we are using MIMO technique, and that was a challenge in release 6, okay, HSPA technique which we adopted in LTE, but it is being later on it was not, okay, it was not taking place. Release 7 onwards it is been included. Multi technique, another one important thing is spatial multiplexing. Spatial multiplexing, multiple independent stream can be transmitted in parallel over multiple antennas and can be separated at the receiver using multiple receive chain through appropriate signal processing. The stream on parallel can be spatial multiplexing we are taking place here. Provides data rate and capacity gain proportional to the number of antennas used. It works well under good SNR and light load conditions. LT standard supports if it's a spatial multiplexing with up and 4 transmit antennas to 4 receiver antenna. Already I have told LT is known for that. Multi-antenna technique, you can see the MIMO with diversity, MIMO with the spatial multiplexing. I told earlier above. So this is one diversity and this for spatial. Here you can see the transmit antenna here, okay, it is getting used, okay, the things, whereas here you can see how exactly it has been taking place and transmit antennas, okay. See there 101 here, the signal, this is transmitter with MIMO, okay, separate multi input antennas. Here it is multi-input diversity. Same signal, it is diversity getting place in entire antennas. Okay. Another technique is multi-user MIMO. Since spatial multiply require multiple transmit antennas, it is currently not supported in the uplink due to complexity and cost consideration, of course. However, multi-user MIMO, MOU means uplink, which allows multiple user uplink and each with the single antenna to transmit using same frequency and time source reported. The signal from the different MIMO user are separated at the base station region. So definitely, which is being, okay, multiplex, to get the things, it has to be demultiplexed at the receiver end, and that is the called base station receiver. Using accurate channel state information, each user obtained through uplink different signal that are orthogonal between users. So that orthogonal code will be using it. Multi-antenna technique, comparison between single and multi-user MIMO, that we can see here. How exactly it is a single, okay, MIMO we are using it. Here we are having entire SS1, SS2, SS3, SS4 signal. It is how it is moving 1 to 4 is only 1 4. At a time it is going, okay, it is going either S1, SS1 to SS4. Here all the signals will be going, okay, sending the antennas, all the 4 antennas using different channel, different signals. That's all. Thank you very much. Today end of my this particular topic.